We were just talking about similar figures and how the ratio of their sides are proportional. And we were discussing how you could set your proportions up in two different ways. So one of the ways was to say left figure over right figure equals left figure over right figure, comparing the corresponding sides. Or we can write the proportion as length is to width equals length over width. And we get the same thing, even though the fractions don't look the same. We get the same thing because we learned in Module 3 that in order to solve this, you cross multiply, so you get 2 times x, and you set your cross products equal. So equals 6 times 4, and look, and I get the same thing here. 2 times x equals 6 times 4. So it doesn't matter which one we use. What matters is that you're consistent. So for instance, this is what I see students do. 4 over 2 equals 6 over x. And I would write that down and put a big cross through it because you went length to width and then width to length. You can't do that. That is not putting the corresponding sides together. So you have to make sure you follow the pattern. If you want to do width to length, you could go 2 to 4, but then over here you have to go 6 over x. So just be consistent when you set them up. And then we divide both sides by 2, which we learned in the last module, and 24 divided by 2 is 12, which is what we got anyway using the scale factor. But sometimes you can't tell by looking what the scale factor is, so that's how we have to make sure we know how to solve proportions. So we got 12 when we use a scale factor. We got 12 when we did it this way. Setting up proportions and solving cross products is useful when the scale factor and ratio method include numbers that are hard to work with. Like what if you had to multiply by 5/3 to get over here? Well, then that's kind of hard. So having this as a backup plan makes it nice when that scale factor isn't a perfect whole number like this one was. Like this one was 3. That's easy. But like I said, if it's 5/3 or you can't tell by looking, then it's nice to be able to have this method to use. So I always look first. If I can see it, times 3, boom, do it. That saves lots of times. But if I can't see the pattern, then what I do is just jump into writing a proportion. Either one, you don't have to write both. Okay, so let's take a look at some examples here. So a toy company wants to produce an enlarged version of a stuffed bunny. The original bunny, so let's underline all this stuff here, is 6 inches wide by 11 inches tall. So when I see what they're comparing, I like to write this out on the side. Remember when we did that in Module 3, Lesson 9, I told you to write it out. That way you won't ever mess up on the order. So you'll always get it right. Remember how I said sometimes students will do this? 4 over 2 equals 6 over x because they're not paying attention to the order. So if you write this when you see what they're comparing, then you'll never mess up the order. So the original is 6 wide, 11 tall. The new bunny, this Easter bunny, 33 inches tall. So I go to the tall, because see how easy, if you didn't have this written to the side, you'd want to put 33 there, right? That's why we do this, so that we can make sure and put 33 in the correct spot. So 33, how wide should it be? So like I said, I always look for a scalar multiple first. If I don't have that, then I jump into doing the algebra. But look at this. Boom. Just like in Module 3, Lesson 9, a lot of them had that scalar multiple. So times 3 to get from left to right. So times 3. And that's really all the work you need to show. So then you can go straight to your answer. So you can see the bunny needs to be 18 and then inches wide. So I should have been a little bit more careful and wrote inches wide, inches tall, because if you just write 18 wide, your teacher's not going to take that. And I'm talking about in future classes, not just this one. So 18, the unit is inches, and then wide. Okay, everybody good with that? I hope so. That's not bad, is it? That would be a good one to put on Alex if it was a no calculator question, because you can easily do it without a calculator. Okay, let's look at this next one. So we have a toy company wants to create a scale model of a sports car for the Christmas season. The actual car, and you can see here they're comparing wide, and this is, do you guys know that's the symbol for feet? So it's feet wide and feet long. So just like in the last module when I was teaching it to you, I would always write those out. Then you won't ever mess up the order on your proportion. So 6 feet wide and 12 feet long. Okay, now the scale is going to be inches and inches, which is okay as long as you're consistent. If these two are both feet and these two are both inches, that's fine. But I'm just writing it in so we know what to write when we get our answer. So the scale is 2.5 inches wide. So I go to the wide and I write 2.5. How long should the scale model be? So I put my X here. Okay, we are ready. So setting our cross products equal, and I don't think anybody sees a relationship. Oh, actually there is a relationship. Slow down, Kim. So the relationship can be from here to here, but we learned in module 3 it can also be from here to here. So do you see what that is? So to go from 6 to 12, I have to multiply by 2, right? So guess what? To go from 2.5 to x, I multiply by 2. And can you guys do 2.5 and 2.5 in your head? Or 2.5 plus 2.5? 10, carry your 1, 5. So that means x is 5 inches. We hadn't seen one like that for a long time, because I think they only had 1 or 2 in chapter or module 3 that had that kind of relationship. But yes, it can be a relationship going down from numerator to denominator or denominator to numerator, or it can be a relationship going across like we've seen several times. So one's called a scale factor and the other one's, I don't know, they have different names, but they use the same concept. As long as you've set everything up consistently, then look for the relationship. Okay, and you could have found it by cross multiplying, setting your cross products equal. I was going to do that, but that would have been a lot more work. 6 times x equals 2.5 times 12. So I was going to make it 2.5 times 12. And so that would have given me 30. And when I divided by 6, it would have given me 5. So I just want you to know, if you had not seen that, which I almost didn't, I wasn't on the lookout for the scale factor going this way, you do get the same answer. So don't think one way's right and another way's wrong. That is not true. And it's lovely if you have extra time on a test and you can do 2 different ways and verify your answer. Okay, let's move on to the next page. So this is the last, nope, second to the last. Okay, so on this one we have wide and tall, and it looks like it's inches, so inches wide and inches tall. And this says a 3-inch wide by 5-inch tall photo excuse me, is going to be enlarged to make a picture that will be hung on a wall. If the enlargement is to be 25 inches wide, so go to your wide, write 25. How tall will the figure be? X. Okay, so now this one I am looking, and 3 can't be, well, it can be multiplied by something, but you wouldn't recognize it. It would be 5/3, so I'm not going to do that. So nothing there, nothing here. So this is an algebra problem. So what we would do is set our two cross products equal like we did in chapter 9, and you can do, or module 3, lesson 9, and you can do it on everyone, especially when you have a calculator. Usually that's, what students result to, but you're probably not going to have a calculator too much on ALEKS, so you'll need to make sure and look for those scale products. Make sure you don't use a calculator on your final exam. It is not allowed. So if ALEKS says here, use mine, fine, but you cannot have one on your test. So just make sure you're careful with that. And then we have 5 times 25. So this cross product is 3x. This cross product is 5 times 25. So 25 times 5 is 125, right? 5 quarters. Yep. So we get 3 times x equals 125. And our last step, which we learned in module 3, is to divide. And it says write your answer, and they're always going to tell you what form they want. So make sure and look. So when it doesn't come out evenly, like this one, 5, 6, 7, 8, 3 doesn't go into 8. So I know it's not going to be a nice whole number. I always jump right up and look at my directions. Write your answer as a whole or mixed number in inches. So it does not want a decimal. So then what you should do is 3 into 125. 3 times 4 is 12. Subtract 3 goes into 5 once. So we have 5 minus 1 times 3 is 3. So my leftover is 2. And remember how that becomes the numerator? So it'd be 2/3. So remainder over divisor. So I can see here x is 41 2/3 inches tall. Okay, pretty good with that. And I see we just have 30 seconds left, so I'm going to end the video so we don't get stopped in the middle, and we'll start on number 4 on the next video.